Yeah, okay.
Great.
Yeah.
Great. Okay. So
Yeah.
super. So I start with what we did within the last weeks, especially Matthew and I. We have questions on agent and agency and the way you look at it, Francis. And you remember that I did send you an email with these questions, and I tried to point it out here a little bit so that we get a clearer picture of how we can understand agent and agency and the relations between entities within a reaction network. And for everybody who is new, what we are working on here in Düsseldorf is trying to model design process or art process with the means of COT, and an important background paper, therefore, is the relational agency paper of Francis. And we had great conversations at CLEA in February about it, and some more questions did arise out of this. And so I want to point out or ask three questions actually, and that's why this little diagram is here. So I just start. Just a question in between. Can everybody hear me? Is it okay? And can everybody see the diagram?
Yeah, I can hear and see it just fine.
Yes.
Okay.
Yes.
Okay, great. So it's a basic setup that we have a performer, a synthesizer, and an idea. And I have four scenarios that I want to map onto this setup. And the first question is, let's assume that so the performer performs on the synthesizer, and out of this emerges a piece of music, and the performer is performing on the synthesizer with an idea of what he wants to perform. Let's say that the idea is that he wants to improvise just on the black keys of the synthesizer, to have a very, very easy example what an idea could be. And so scenario one would be, oh no, and let me take it, and I wrote out three definitions out of our conversations we had together with Francis, what an agent is. And so let me read this out. So an agent is necessary for a process and is there at the beginning and the end of a process, is one of the definitions. Another one is an agent is the enabler of a bundle of actions that act on the present situation to drive it towards a restricted set of attractors. And the third definition is agent produces its own constraints that keeps it going. Okay, and if we look at scenario one and we say, let's model it like that the performer is the agent, then the question is, what is the ontological status of the synthesizer and the idea? So my question is, if the performer is the agent and he's the driver of the whole process, because the performer has the idea to perform on the black keys of the synthesizer, and then is the synthesizer a species, or is it thinkable that the synthesizer is also an agent? This is question number one. Francis, what would you say to this? Would you distinguish once there is an agent defined within a reaction, are the other participants then of the ontological status of species, or can they be agents too?
Well, I'm inclined to say that they can be agents, because you want to be able to model interactions between agents, which means that you need to have reactions with more than one agent. And in this case, yes, I'm inclined to say that the synthesizer may also be an agent.
Mm-hmm.
Though, yeah, maybe the question is whether the synthesizer alone would be able to start any reaction. And in that case, maybe it's only an agent if it is combined by another agent that starts the action.
Okay.
It's a nice example, actually, because in this case, it's a tool, which means it's a necessary condition for the action to take place. But the tool on its own will not start the process. Maybe we should invent something like a tool as being a necessary condition, but which will not on its own start a reaction.
Okay, great. Great. The second question is...
Sorry, Christian.
Yeah?
Christian,
Yeah.
one sec. I think it will be nice to hear what Yogi is saying, because Yogi has a Templeton project on agency, actually. And
okay.
I was checking his website before the meeting,
Yeah.
and there is a test that tests notions like what is an agent, what is agency, and another that I don't remember, like a system. You can tell us, Yogi, please, because I think it will be relevant to have your view as well, if possible. Thanks.
I had a quick look at France's framework. It's completely different. I use agency for living agents, living beings. Nothing else has agency. So Latour uses actant for this sort of causal influence that we're talking about here in his actor network theory. Maybe that's a better word, because that's less confusing. But I know that Francis has been way before me using this term. There's two very different research traditions here. One is second order cybernetics, and it's sort of split up. So I'm more in the tradition of Varela Maturana, and I would use agent only for living beings to set them apart from the non-living.
Okay.
Okay. So
great.
So there is a more cybernetic view that does not make a distinction between living or organisms, and another that does the distinction. Is that the case?
Exactly.
No, I wouldn't say it's a cybernetic view. It's more kind of the view from complex adaptive systems, where you define agents as anything that follows some condition action rules. So the agents could be molecules, or they could be cars, or they don't need to be living, but they react to conditions by performing actions. So but I mean, I don't mind the terminology of actant or actor. I'm not quite sure in Latour what's the difference between an actor and an actant. I've seen both terminologies. I don't know what is the difference.
If I could ask you a question real quick, Yogi. I think it depends on like how you define, I guess, a living organism or like a living system. Could, for example, like a social system have agency in your opinion, or would it just be an actant, or is it a matter of definitions and it's not that good?
No, so the distinction. So I'm more in the tradition of Robert Rosen. He calls everything that's not an agent a simple system. So for him, all physical systems that are non-living are simple systems, which is not the usual way of the word. So I'm not using that in public. So Rosen then calls systems that have hierarchical cycles in them complex. And complex systems include agents, which is like an organism, and also ecosystems, social systems, which are agential systems. So they are systems that have no higher level closure like an agent does, but it contains agents. So at a lower level. So that's the sort of conceptual system where I would come from. But these are just, I mean, it's good to clarify these words. I would like to actually hear what you guys have to say, because I'm now clear what an agent is, or maybe I'm not clear about it, but I'm clear what I don't understand, at least.
Okay, I proceed then with my second question. I think this is a good. The second question, Francis, we touched it already in February. The second question is if it is possible that the idea is the agent. Let's say, as we said, that the idea is just to play the black keys on the synthesizer, and then the idea is the agent. And then, first question: do you think that this is possible too in your frame of theory or looking at things?
Well, in my frame, I use a very broad definition of agent, which maybe is a little bit too broad for the more intuitive meaning, which is that an agent is a catalyst of a reaction. That means that the agent makes the reaction possible, which otherwise would not happen.
Mm-hmm.
So the ID in this case is a catalyst of the reaction. The ID is necessary for the reaction to happen, and the ID itself is not directly affected by the reaction.
Mm-hmm.
But generally, we would say that the ID is the product of the musician. So in that case, there would be a previous reaction where the ID is produced by something which is then the agent of the ID, and then
Yeah.
it becomes kind of an intermediate stage in a sequence of reactions.
Yeah. Great. Yogi, anything you want to add from your perspective from the
No,
classic?
this was very helpful. So Rosen calls this a processor. Okay, so I have a better idea now what you mean by agent. Thanks.
Okay. So what Rosen says, processor to idea especially, or to agent?
No, any efficient cause, something that makes something else happen.
Okay, a processor.
Yeah.
Okay, great.
I have a little comment here, because the idea we were discussing with Christian. That's topic for another meeting, but
Yeah.
a little background. When you say idea, or when you put idea there, this idea is an idea that is outside the agent, the any other agent. It can have an ontological independence
Yeah.
from other agents. So, but maybe this could be confusing, because the idea is in the performer. Or can we attribute it an existence outside the performer?
Yes,
So,
this is a good
I think
question.
this is a very important distinction, depending whether we, okay, and then I don't know what the answers will be on each case.
Yeah, absolutely. So this was what we were talking about, Thomas. The one possibility is that the idea is a property of the performer, so a property of the agent, actually. And the other possibility is that the idea is has an ontological independent status, and even more, that the performer could be taken by the idea. And this is a complete different
that's the most interesting even.
Yeah.
But back to what Yogi was saying, I think if you could elaborate maybe a little bit further, Yogi, on the hierarchical cycles. I think you said that these are like complex systems or complex agents. You said, and you were following Rosen's terminology, and you said when they contain agents, they are something. I think you introduce a term, and they are not necessarily agents themselves. So then what then the idea performer synthesizer will be a triad forming such a type of structure then. So I think it would be nice to explore these concepts in this idea. So please, if you can.
Sorry, I don't want to hijack the meeting here, but yes, so the idea there is that agency is reserved for the particular behavior, the self-manufacturing, autopoietic dynamics of a living system, which is the defining characteristic of a non-living system. And these systems, they are deterministic. They can be deterministic, but they have this self-referentiality. They have a kind of a circularity, which is not just cybernetic feedback. So this came out of Rosen first, and then also Matrana and Varela, but in a much more, in a less formalized way. And so the idea is that these systems have fundamentally different type of behaviors. And what's important there is that they cannot be captured by normal Newtonian physics and mechanistic explanations. So this is agency is used in that context to distinguish something that has this type of behavior, while from my reading of Latour, that's more about causality, efficient causality in systems that are not necessarily living, but are containing living agents. And so in the framework we're using, we're calling those agential systems because they contain agents. So an agent itself is also an agential system, but what Rosen calls complex systems comprises both organisms as agents and then also the systems that are built from on top of agents, ecosystems, social systems, the economy, whatever, and technological. and the evolution of scientific knowledge, of course. These are all agential systems then. So I don't know if that's helpful, because it's a completely different tradition as far as I can understand.
But I think it's super helpful really to see these two different kinds of views, because this is a lot what I think this helps very much to clarify.
Yeah, I agree. If I could ask you another question real quick, Yogi. With those kind of systems, and I think especially with this example, we're kind of like looking for like the specific agent. Like, is it the idea? Is it the performer? Is it the synthesizer? But in like those kind of like more complex systems, would it make sense to view kind of the context itself as the agent or the agency, instead of the agency being within one particular thing? Would Rosen say that it's kind of the context itself, this like the overall system itself, that kind of enables, or is it in a particular, I guess, species or a particular agent?
So the agent does two things. It constitutes itself. It's autopoietic. So that's what makes it an agent. And it is an agent because that type of organization allows it to initiate causal effects from within its organization. And the trick is that from the outside, you cannot take it apart without destroying the agent. So you cannot study that kind of agency. So you cannot predict what the agent's going to do. And so it becomes an autonomous agent. It has a certain independence of what you can know about it. So it can always do things you don't expect it to do. So that's the idea. And then there's a second dimension to agency, which is the interactive dimension, where it interacts. An agent has to be aligned with its environment. So what we're talking about here is the interaction of the agent with the environment, and the agency is still in the agent, but of course the agent needs the environment to survive, and it needs to be aligned with the environment to survive. So it affects the environment through its actions, and the environment affects its actions because it is open to formal cause, not efficient cause. So it basically changes its shape depending on what's happening in the environment. So Maturana and Varela call this structural coupling. It's full of these words that nobody understands. I'm sorry, I'm just throwing those at you because this is a whole tradition that is quite
but this meeting is to clarify or to advance on those full of notions. So we need to find the language.
Great.
So
But
Francis, Francis, are you still there, Francis? Yeah, because I was wondering if you conceive the idea within the performer or outside the performer when you were building your argument. Do you find that this distinction makes a difference in your view of whether or not the idea is an agent?
Well, I would also want to say that in my approach, there are two agents. You might say a simple agent and a complex agent, where the complex agent is like a chemical organization. That means it's a network of self-maintaining processes, a little bit an autopoietic system. So in that sense, it fits in with the definition of Yogi, but which from the outside behaves like a catalyst, which means that from the outside, it participates in reactions, it transforms some input in some output without you knowing what's going on the inside. So I use the term agent both for simple agents, which could be, let's say, a molecule or an idea, or potentially a synthesizer, and then for complex agents, which could be the performer. So it's just to have a language that can describe complex things in the simplest possible way. And that's also a little bit what Latour does with this terminology of actants or actors. Anything can be an actor, anything can be an actant. You make networks with them. The problem is that, as far as I know, in the actor network theory, there is no formalization. You draw networks, but it's not clear what the connections mean. While in COT, there is a clear interpretation of what the reactions mean. And then the point is, things that look at one level like a single agent, if you go more deeply, it may actually be a whole chemical organization of interacting species.
Yeah. Francis,
Actually, sorry, Christian. I think it's very nice that this what Francis said, because at this view where we have the idea, the performer, and the synthesizer, we see these three nodes as if they will be sort of objects, if there will be like chunks that we talk about them as an entire things. But of course, I guess we should have to go one level deeper, and then formalize or try to make a model of the internal structure of the idea, the internal structure of the
Yeah.
performer, and the internal structure of the synthesizer, to understand how they relate really as a complex system.
Yeah.
And this is more or less the intention of COT, or the approach that we follow with Francis, which is recursive in depth.
Yeah.
The representational depth can be recursively explored. So we start with this general idea, but then we can go deeper, trying to find these complex cycles or organizational structure, and depending on the tradition we follow. But
Yeah.
very cool. Yeah.
Yeah,
Sorry.
great.
That I just wanted to add that for clarification.
Yeah, this is great. My last question is the distinction between the words agent and agency. Francis, do you use agent and agency interchangeable, or is it thinkable that, for example, the idea and the performer, if we look at them as two agents, that they build together an agency that they wouldn't have if they would be on their own?
Well, in my paper, but that's just this one paper, and I'm not sure whether it's generalizable, I define an agent as a localized agency. And the example I give, actually, I think the example was left out of the published version of the paper because the referees were confused by it. The example I gave was gravitation. Like,
Yeah.
gravitation is an agency. Without gravitation, heavy things would not fall down, but gravitation is not localized.
Yeah.
Wherever there is a mass, there is gravitation. So you need gravitation to make the massive object move towards another massive object, but the gravitation is not an agent because you can't localize it. So that was my idea.
Okay. Okay.
Agency then would be just a more general term for some necessary condition for making something happen, which itself is not affected by the process.
Yeah.
So that was my idea of agency. And then an agent would be a localized agency. That means that you can clearly say that it's separate from the rest. Like the performer is obviously an agent, the synthesizer is obviously an agent in that respect. The ID may not be, in the sense that the ID, if it's an ID that is generally spread, we can't quite say where it's localized.
Okay, great. And what do you think about the idea? Because Matthew and I came up with this idea when we had a conversation that if two agents come together and they react together, and is it possible to think then of agency, that the two of them produce an agency which emerges from two agents? And could we then talk also about emergency? We came up with the idea of, let's say, the Beatles. The Beatles, their impact, so their agency on culture was bigger, the four of them. If you look at the four Beatles, John, Paul, George, and Ringo, as single agents that work together, and an agency emerges that is much stronger than the impact that every one of them would have had if they would have been on their own. Is this a thinkable way, or is this something completely different?
In this case, I would not call the Beatles an agency, but a super agent. It's an agent out of agents. And I just heard a paper about emergence, where I define emergence as the fact that there are properties of the whole that are not properties of the parts. The whole can produce music that none of the parts alone could have produced.
Yes.
So the definition of an emergent property is actually very simple. That is, a property of a system is how it reacts, which output it produces in reaction to a certain input. If the system consisting of several components produces a different output for a given input than each of the components would do on its own, then there is an emergent system. So in the case of the Beatles, you might say the input may be IDs, or I don't know, the culture, and then the output would be the music. So as a whole, the group would have produced music that none of them would have produced on their own.
Great, but so in distinction to agency, in this case, you have the name super agent.
Yeah.
Great.
Or emergent agent, yes, super agent. I would call it a super agent.
Okay, super. Well, this
is it somehow connected to the hierarchy which Yogi mentioned before? Because it looks like if it's super agent, then it has some priority on other agents. So for example, Beatles is higher or has a higher prior than other music bands, I don't know, school bands and stuff. Well, so it means that between agencies, there are also a hierarchy.
Well, there is a hierarchy, but also only in the simple sense that something is composed of components. So it's the terminology in biology or in systems theory. A super system is a system consisting out of component system. A superorganism is an organism consisting out of other organisms. For example, a multicellular organism consists of cells. Each cell on its own is an organism. So a multicellular organism is in a sense a superorganism. Does not mean that it is necessarily better or higher, but it contains the things as components. So a super system contains systems as components. A super agent contains agents as components.
Oh, okay, understood. So it means that just Beatles, because there are four of us, they built their super agency. But why then they are agency of this chain culture, music culture with idea and music as output, but not another band, for example? Is there still some hierarchical context or not?
No, I would say any band that together can produce more than they could do individually. Of course, you may have some bands where each member composes his own songs, and then it's not really a super agent in the sense that it's just what I call an aggregate of agents. So each of them works completely on their own without in any way being influenced by the others. Then it's just a group or an aggregate. It's not a super agent. If they do influence each other so that together they can do things that they can't do alone, then it's a super agent.
Okay, so inside of the systems, they don't have a feature like impact or importance. So even on the examples of super agencies or agency, because it looks like even super agencies have their own impact on the system, and this own impact is part of system and is a feature of the system or not.
Wait, I didn't understand. You mean the impact of the whole?
Yeah, so for example, impact of Beatles on the system will be like X, and impact on another music band, which is also super agency, is Z. And I wanted to ask if this impact X and Z somehow defined by the structure of the system or not.
I think it's individual for each system. Each system will be different. That means both the individual components will be different and the way they interact will be different, and therefore the impact will be different. I think it's only in very simple things like molecules. You can say two molecules which consist of the same atoms have the same impact because they are exactly the same components and exactly the same way they are arranged. But two music groups obviously will be different.
Yeah, so exactly. So I wanted to ask, is this impact, even individualized and of course individualized by any system, is defined by a structure of a system? So it's something that it's a property of the system. This is something like if we have it, we can say, yes, it's a system because it has individualized impact of agencies and stuff. Because we talk a lot about the structure of systems, we talk about agencies, pieces, and so on. But obviously, there are some hidden properties which they are said define that the system is a system. And I wanted to ask if the impact also play a role here. But I think it plays.
It will. I mean, yeah, it will. I mean, it's like maybe simpler example is biology. An organism is this chemical organization of autopoietic arrangement of processes, and two different types of organisms. They are differently organized. They have a different metabolism. Therefore, they will have a different impact. They will. Maybe the one will go well in one kind of ecosystem, the other one will go well in a different kind of ecosystem. Maybe the one will produce a lot of food, the other will produce less food. Depending on the organization, the impact will be different, of course.
Thank you.
Well, Francis, thank you very much. These were my questions, and I think I pass on to Matthew.
Yeah, sure. Sounds great. Yeah, so I guess today the reason we're having all these super technical definitional debates, it's kind of like we're trying to get a sense for what terms we want to use, like precisely for like the models we want to make. So like when we say a certain thing, we know exactly what we're talking about because it can be the case. Like even just before, I mean, there are a lot of definitional kind of nuances, I guess. When someone says like agency or agent, it can kind of be used differently, and especially like within our small group, we want to make sure that when we say something, we really mean or and are on the same page. And it's also kind of interesting to point out or like important to consider that these are kind of could also be like in the process of being learned as well. It's not like and I think a lot of these definitions are like very great, but I think together, I think through these kind of conversations we can like get definitions that kind of make sense for us, particularly like in the COT framework. So the COT framework, for people who aren't familiar, is basically a modeling language to consider how I guess like one thing leads to the next. So it's like a modeling language that can kind of model processes, and that's not very common. It's quite a unique thing. And I can't share my screen because I'm recording, but here's a doc that I made um, earlier, and maybe yeah, maybe Christian, would you mind sharing your screen again and just opening up that doc? That might make sense.
Did you? You send it, right?
Yeah, I just put it in the chat. So
Yes.
yeah, I just kind of want to raise two questions for like what terms we want to use as a group together, as it relates to, particularly today, I think as it relates to agent and species, because I mean, for one thing, like as we were talking about before, it really depends on the level or like the context that you're considering something. So like the Beatles, for example, could be viewed as like an emergent agent, I suppose. But like Paul McCartney might also be viewed as like an agent. It kind of depends on the scale of things. You can scroll down, I guess, to the COT diagram we usually refer to. That would make sense. This one
This
right
one
here.
here.
Yeah. That one would be fine. Um. So, um. Yeah. Maybe to give like a little more background, I guess. Uh. One way to view an agent is based, and I think the way that we kind of should view an agent or a species, we kind of have this like object-based view where we say like this is a species or like this is an agent, like the beetles are an agent or like this particular molecule is an agent. I would really like to like open up the floor for us to consider, because based on the relational agency paper, I think this makes more sense to really view agents or species as conditions more strictly. So when we consider something like in this particular framework here, instead of viewing it really as an like a molecule, we could view it as we kind of intuitively view it as an object. But within our models, I think it makes sense to start calling them conditions opposed to species, just for like the sake of simplicity, kind of. And I'm really curious what you would say, Francis, about this. Whether in COT models, it would make more sense to call them conditions opposed to species, or Yogi. But yeah, Francis, I would love to get your opinion on that if possible.
Well, I've never really liked the terminology of species. I have been more calling it molecules, but that's also not a good terminology.
Yeah.
So maybe indeed the terminology of conditions is better in the sense that I use the condition as the most general kind of distinguishable thing. You can distinguish something. It means that you can make the difference between it being there and not it not being there. A condition may be it is hot, or a condition may be there is H2O, water, or a condition may be there are the beetles, or a condition may be there is gravity. Anything where you can distinguish between the presence of something and the absence of something is a condition. And a condition means that something needs to be there for the action to take place. If there is no gravity, the object won't fall. If there are not the Beatles, there will not be the song yesterday. If there is not this molecule, the reaction will not take place. So in that sense, for me, condition is about kind of the most general term for something that you can distinguish presence or absence, and that is necessary for something to happen.
Yeah.
Sorry, Thomas.
Go.
And the condition could be anything. Could be physical. Could be an idea. Could be human.
Yeah.
Is it like that?
Yeah.
I actually have another. Well, no, it's not. It's a complementarity, because that's something that Francis was referring to. It is something that just to be that something. It requires a little bit of regularity in the world. So we cannot call, for example, a spontaneous. Let's say that there is one condition that happens only once in one specific time, in one specific place, and never again, and never else. So that condition skips a little bit the meaning of what we try to capture with the notion of species. So there is some sort of regularity that is observable. So that's why we call it something. That thing of we as scientists or whatever trying to give meaning to things of giving the ontological status of something, it's already a lot. So that's why I used it. I have introduced term, but not in any paper yet, the glued qualia. So it's a collection of it's a qualia, a set of things, a set of properties, or set of distinguishable things that come together. And when they come to, it can be one or it can be many, depending on where do we start from in our notion of property or qualia. But I think it's the most fundamental thing that when these qualia come together, not necessarily in space, not necessarily in time, but together in our representation, then we will call it to be that something of the world. I think that it's very important to dig deeper on the notion of what is that something in the world that we tend to like. Something isn't a song by the Beatles too. Something in the way. Yeah.
Yeah, something.
Yeah. So the notion of something, it's I think it's very deep, and I call it glued qualia. I suggest that this could be an interesting notion to explore. Yeah.
I'm not
Yeah,
convinced.
Thomas, I have.
I'm not convinced by the term glued qualia, but I agree with Thomas that there indeed must be a regularity. Actually, the concept comes from my PhD thesis, where I introduced the concept of distinction as kind of the most primitive unit of any kind of a cognition of the world. How can you know the world? First of all, you need to make distinctions, and distinction is not just a difference. It's not just that something is different from something else. It means that it is a difference that, as Thomas says, that repeats itself, that is appearing in many different places. Something that happens uniquely once, it's not a distinction, it's not a condition. You can't name it because there is no regularity. It is something that can come in different moments, in different places. Like if you speak about gravity, we know that the gravity here and on the moon are both gravities. The strength of the gravity is different, but the laws of gravity are the same here and on the moon. We can distinguish, and we say there is gravity on the moon, there is gravity on Earth, but there is no gravity in outer space if you're far enough from any massive body. So distinction means you can distinguish between present and absence, but that distinction is something that reoccurs in different places. It's not just once. Here, it's regular. It's repeatable.
I have a question to this. It motivates me to come back. Sorry.
Another possible terminology that I sometimes use is category. A category means things that are considered equivalent in a way, but that are distinguishable from something else. Like a species is a category of organism that we typically see as being similar as far as we are concerned, but that is distinct from a different species.
Yogi, you were about to say something? Hand raised.
I have questions. So I would use Bateson, Gregory Bateson. His term of information is the difference that makes a difference. So he says the world, the physical world is devoid of distinctions. The humans in interaction with the physical world are making distinctions. And what arises from that is his idea of semantic information. This has nothing to do with Shannon information. So it's a difference that makes a difference for you. And this is connected to how an organism experiences its world. So we live in a world that is large. So a lot of the features and the problems we encounter in this world are not well defined. So our first problem that we need to solve is the problem of relevance. We need to pick out from that world what is relevant. But that's a little different, I think. So my question is how this relates to your terminology. So that's a bit different because the factors that are relevant in a situation are not necessarily regular. So that brings me to the definition of a system, which is, again, Robert Rosen's idea. So he says you do science in two ways. First, you have to make the distinction between yourself and the rest of the world. Otherwise, you can't do science. The second is you have to distinguish systems in the world. Again, this is solving the problem of relevance because you have to pick out the factors from an undefined environment which constitute your system, right? And so I'm trying to map these concepts of a condition and all that onto this. So the condition, if it's something that is picked out, it seems like it's a difference that makes a difference a la Bateson, but Bateson doesn't require it to be regular and reproducible necessarily. And Rosen's term of a natural system is basically that it's something, it's a regular pattern. It's something that we can pick out and measure. So he has a book that is less well known than his life itself. It's called The Fundamentals of Measurement. And he defines systems in terms of sets of observables that we can measure that then map onto something out there that is undefined and not formalizable. And getting from that unformalizable encounter with the world to this formalized system is what he calls doing science, actually. So now I'm wondering, so I would call, I think if I get this right, so the condition here is a certain state of the world. So I have this initial condition in my mind when you say condition, and then there's a system which is the agent, as far as I understand in your framework, Francis, that Rosen would probably call a natural system that somehow gets the world from this one condition to another condition, right? So I'm asking here. I'm trying to make bridges between the two conceptual worlds.
Yeah, actually, if I could pop in real quick, Christian, you mind like scrolling down a tiny bit? See that second, these 3 bullet points here?
Okay.
Wait, no, go up again.
Back?
No, yeah, go up again. Back up. No, back up. These 3 bullet points here. Yeah, Yogi, what would you say about Yogi or Francis, like a definition of system being about like this set of repeatable conditions? And also based on what we were saying before about conditions, I think it's also important to emphasize that conditions are a process based on what we were just saying. It's not like a condition is just something that happens and it's like bang, it's done. It requires a context. It is the process in itself. So I think that's really important to emphasize when talking about conditions.
Okay,
And
so in that case, can I throw in the question, how is it different from the system itself then? I mean, for me, the system is all systems are processes.
Yeah. How is
And
a condition?
a natural system, also according to Paul Weiss, is something that is a regular, it's a sort of a pattern in reality that we can pick up on.
Yeah. How is a condition different than the system itself? Yeah, that's a great question. I mean, I don't know. It's a great question. But I think that's what we kind of have to answer too. Like how do conditions fit into the overall agency or system? And by the way, like when I say agency, I kind of mean system as well. And one way to maybe think about it is just the fact that these conditions share a space and have been self-organized together is one potential way to think about it, maybe.
Well, I like what Yogi was saying, and I agree about it. And Bateson's difference that makes a difference is always been for me one of the most fundamental guiding principles. So a condition is a difference that makes a difference, but you assume that you can recognize a similar difference at a later stage because we are trying to model. Modeling means you have a formalism that wants to make predictions. If I put A and B together, then C and D will appear. That means that at a later stage, the conditions will not be exactly the same, but at some level of abstraction, you could say there is an A and there is a B. So the A and the B in the first case and the A and the B in the second case must somehow be recognizable. So they are differences that make a predictable difference, not predictable in the deterministic sense, but in the sense that we know that when A and B get together, this tends to happen, maybe with this probability or this speed or whatever. We want to be able to say that any moment you put an A and a B together, something will happen that we can describe as a C and a D. So that means you need to assume that the A and the B in the first case and the A and the B in the second case are somehow the same. And that's the abstraction you make. You look for differences that make new differences that are to some way predictable. I'll give an example, a counter example where you can't do that. We know that radioactivity means that some nucleus of some radioactive atom at some random moment will fall apart, it disintegrates. But we cannot predict when that atom will disintegrate. So we have an initial condition, the radioactive atom, and then we have the final condition, the disintegrated atom, but we don't know what is the additional condition for this to happen. Some random moment, the radioactive atom will disintegrate into two atoms, but there isn't an additional condition that we can recognize. There is no recognizable cause for the radioactive atom to disintegrate. So that is the case where you don't have a difference that makes a difference. You don't know what is the difference that made that this radioactive atom disintegrated and the other radioactive atom did not disintegrate. as far as we can see, all the radioactive atoms are exactly the same, and yet after a particular half time, we know that half of them will have disintegrated, the other half did not disintegrate. And we can't say what's the difference between the one that disintegrated and the one that did not disintegrate. So here you can't model precisely the process. You can only model the process statistically, namely that after a certain half time, half of the radioactive atoms will have disintegrated. You can't say what it is, what is the difference that will make the difference, namely that one atom disintegrates and the other one doesn't. So this is to give a counter example where you can't do this. So what we are trying to do in modeling, we are trying to find some recognizable condition that tell us in this condition this thing will happen, and what will happen then is another distinguishable condition. So that is the idea of the repeatability. The conditions should somehow be recognizable and lead to recognizable results. So you try to achieve that, but in some cases you can't, like in the case of the radioactive atom. The process intrinsically indeterministic. So you can't say what is the precise condition for an atom to disintegrate.
Yeah, and I want to add a little bit extra to this, which is that it, the difference that makes a difference and the notion of regularity and so on. That Yogi was mentioning that we because where does the sorry, where does the regularity come from? It comes from the regularity of our senses in the end. Because when we speak about modeling and about creating criteria of relevance of what will be the stuff that the world is made of, I think we tend to assume that our measurements of the world are stable. I mean, if we measure the world twice, we will be measuring the same thing in the same world. So I think it's a very important aspect to take into consideration as well, that science has attempted to make this assumption kind of justifiable, and this is not always the case in all sciences, like in social science or in art. Maybe if we try to study creativity in the arts. So it's very relevant to think of this underlying basis of what is the stuff that makes a difference. What is the difference? What are the differences that make a difference? So if we are like really fundamental about it, we might not even assume a priori that the senses that perceive the world are constant, are reliable enough to speak about differences that make a difference in a regular way. So I agree with this, but I think that for the sake of modeling, we tend to make this assumption, uh, or believe at least that this works. I don't know if this makes sense, but I think it's a deeper layer, a next layer of this idea of a distinction that makes a distinction, or difference that makes a difference.
Yeah, I think maybe by next meeting we can try and like get a sense for what exactly we mean by condition, or and kind of like as it relates to information too, because I think that's kind of at the heart of what we want to find out with COT. Like what, how do we consider conditions, I guess, and how do we consider it in that sense that you were just talking about, like with sensitivity, how it can be different, and also the difference that makes a difference. I think, and I first thing I would ask, kind of as I was saying before, or like the question that I think we should maybe try and answer by next meeting is, should we view what we've been calling species as conditions, for the sake of simplicity? Because I think it might make sense just based on what we've been talking about, because ontologically everything in the model is kind of on the same plane if everything is viewed as a condition, um, whether it's, um, as we were talking about with the example before, like the synthesizer, the idea, and the person, they're all kind of conditions in some way, and they're all kind of in that way they all kind of fit ontologically in the same model, I think. So that, I mean, that I think by next meeting that's kind of what would be nice to.
Yeah, Francis, can I ask, is it like that? So would you say that the performer, the synthesizer, and the idea that they are all conditions?
Yes. Well, I wanted to make one more remark about what Yogi said about relevance. So, what are relevant conditions? Relevant conditions typically are differences that make a difference. That means that you distinguish something which you know leads to some future difference that you can also recognize. So one condition that leads to another condition is a meaningful condition. But if there is a condition that does not lead to any other condition in any kind of a predictable way, then it's not a good distinction. The example I give in my courses is this famous thought experiment about consciousness, the zombie thought experiment. So the philosophers like David Chalmers imagine that there are two types of agents. There are the humans that have consciousness, and then there are the zombies that don't have consciousness. But they assume that you can't in any way distinguish between the two because the zombies behave just like normal humans. So if you ask them, for example, if you prick them with a pin and you ask them, did you feel pain? They will say, yes, I felt pain. But actually, they don't feel pain. So the assumption is they behave as if they feel it, but they actually don't feel it. So I give that as an example of a badly formulated problem because you start by making a distinction between zombies and people. It's a difference that does not lead to a difference because the zombies and the people behave exactly the same. There isn't any experiment you can do on a zombie that would identify that as being a zombie and not a human. So that for me is an example where you create a wrong distinction. You assume a bad condition. It's a condition that is not relevant. It's a condition that doesn't make a difference. So the difference between zombies and humans, to me, is a meaningless distinction. Being a zombie is not a useful condition. You can't make any predictions from the assumption that something is a zombie. So the zombie species in your COT reaction would not make any difference from the human species.
I'm loving this. I'm loving this, Francis. I have very similar feelings, including emotions, about David Chalmers and much of his philosophy. Yes.
Quick question, by the way, about David Chalmers. Wasn't there like I saw something on Twitter like 2 days ago. There was like a bet that they made, like whether consciousness could be solved by like in like 25 years or something. And I think
Chalmers won that bet for all the wrong reasons, and everybody says, "Oh, see, Chalmers was right," but Chalmers is crazy. He has this is really not something you should take serious.
Okay, yeah, it was a headline, and I was like, yeah.
Francis, can I ask one more time just to be sure? So synthesizer, performer, and idea would be a condition in your framework.
Yes.
Okay, but then there is this distinction between agent, which is a condition, and other conditions.
And there it's indeed a bit more tricky. So my definition is very simple and probably too simple. That is that the agent is a catalyst. That means the agent needs to be present at the beginning and needs to be present at the end for the reaction to take place. So
yeah, I see.
That's the definition, but it's a definition that's very broad and maybe too broad.
Mm-hmm. Mm-hmm.
Yeah, which is why, I mean, one way to think about it is that you consider the entire reaction system or the dynamical system as the agent or the agency, because it does enable and it does maintain. It's not it's not like it's not the synthesizer itself or the idea or the person itself, but like the overall space or context which is shared. It does enable and it does maintain. So I mean, maybe it might be one way to consider it. I'm not sure.
Well, the whole idea of the formalism is to have the simplest elements be able to organize into something much more complex, and then the complex thing, again represented in the same way, so that you don't a priori make a difference between the system and its components. You're not making a difference between the actual chemical molecules and the organism that they form. Of course, there are differences, but within the formalism, both should be able to be represented in the same way. And that is why the formalism is intended to be this transdisciplinary formalism that you could, in principle, apply at all levels, from the level of society and ideas to the level of elementary particles and gravity. So that's the idea.
Yeah. The exciting thing to me is because it depends on what I assign as an agent, and it becomes a completely different modeling of the process. You know, if I start to say that if we stay with idea performer synthesizer, if I start saying that the idea is the agent, the process is different than the process is when I say the performer is the agent. And this is somehow exciting, you know, because it's.
Why is it different? Why is it different if you just say synthesizer plus performer plus ID gives music plus performer plus ID plus synthesizer? What's the difference?
The difference is that suddenly, if you say that it was what Thomas and I we were discussing about it, it's always about, to me, about this ontological status the conditions have. So that I really can say then that the performer is let's say taken by the idea, so that the idea is the agent and really the driver of the whole situation. And this is ontologically, I also would say, in the modeling something else than if you say the performer is the central agent, who is there at the beginning, who is there at the end, and who is not touched by the whole process, which of course is not true, because the performer gets changed during the performance, although he is the agent. But we had this discussion, which was great, when you agreed that we can say that the agent can have a state, and that the state that we have two parts of the agent, one part that is unchangeable and the other part that is changeable. And you know, and this is super interesting, that you really get different models. And it's about, and maybe this is important, because it's about because what we are doing here is not so much to use the modeling for prediction, but to see more clearly what the process is that is going on. And of course, then the hierarchy and the impact changes. Whatever is the driving force, whatever you put forward.
Well, I don't know. I think it depends on your model. Your model can be more or less detailed. Can, for example, take into account the mental state of the performer, and then you can go into many different directions depending on how you elaborate the model. Looking at the ID as an agent can probably inspire you to develop the model in a different direction. But I would not say that it is intrinsically implies a different model. I think it's more the reason to call things like IDs or synthesizers or even molecules agents, it's kind of a heuristic idea. I think it's also a little bit what inspired Latour. Like, if we always think that agents need to be these intelligent human beings that have clear goals and strategies, etc., then we tend to look at everything else as just passive material, and it's not that passive. It does participate in the process in an essential way. And calling it an agent, I'm still not sure whether that's the best terminology, but calling it an agent reminds people that yes, That's part of the process, and the process is the essential thing. It's not matter. It's not just objects passively waiting there until some agent uses them. No, the objects, the matter participate in the process.
Yes, it's like this was the other scenario that I didn't mention, but you mentioned it already, that the synthesizer could also be seen as the agent, for example, with its possibilities. It's there from the beginning until the end, and it makes this whole process possible. To play music with a synthesizer actually is the process that is only enabled by the synthesizer. And then, of course, the synthesizer also constrains what is possible. And so it keeps itself, as you say, it keeps itself stable. So you also can look it from that way. And then suddenly the performer is just, so he's in the role of the tool suddenly. But this is, of course, this is all these Latour ideas and Friedrich Kittler ideas and so on. This is, and maybe it's also interesting that this is maybe also a good thing that maybe you say that the process does not change that much because it doesn't matter if we have idea, performer, synthesizer, and these three conditions makes a piece of music emerge. Maybe the difference really lies more, let's say, on the humanities kind of level and all these theories that are out there. And you can use, let's say the Latour theory, and with this light, the process changes. And if you put another theory of Friedrich Kittler, if you shine the light of this theory onto the process, it becomes, on this level, another kind of process in the interpretation of the process. This might be another level, this interpretation level.
Yeah, it's a good question. I actually didn't fully grasp everything that was going on there. Could you maybe sum it up real quick? There was, yeah, in like one sentence or one question. It was
what?
Yeah. So it was how. Yeah, could you just repeat the final question? I didn't fully get it.
No, it's just an idea. It's just an idea that came to me through our discussion here.
Yeah.
And
Okay.
I can't formulate it clearly at the moment. It's
Yeah, all these are open-ended. I do have well, there is a question from May. This is a great question, actually, and I think this really plays to the other example that we might talk about. How does the perception of time, or even just time generally, maybe matter in the stability of a condition? Because taking the music example, like where these things happen, we can model them happening like real quick, like the synthesizer, the idea, the performer, something that happens kind of within a matter of seconds or minutes. But if we modeled something over time, and I think maybe next meeting we could talk about this more, because we are kind of running out of time here. How we would want to maybe model CLEA or even our own research group in COT, because this example would consider time in a completely different way. Because the music example is really, the reactions are pretty instant, but processes that happen over longer periods of time, or conditions, we might say, that happen over longer periods of time. I think that's a conversation worth having. Probably next time, though, because we are.
Yeah, but I think Francis and Yogi, thank you very much. This was a great session, I would say, for clarification.
Yeah.
Of the of the different frameworks and notions. And this was a really super helpful session.
Yeah, thanks for having me, and I will look up Francis because I have not come across you, and I like your ideas. So it's really nice to meet you, by the way. Yes, and Matthew, I'm still a little confused about what you guys are trying to model. Is there something I could read to get a bit more context about what you guys are actually trying to do?
Yeah, it's a work in progress. Let's say we're really trying to figure out. I mean, I guess anything really, but I think a good idea would be to model Clea, like as like a
To model yourself as an institute.
yeah, right. I mean, because we might even be able to consider like perspective in it as well. We'll
But
see.
it will be. Let me add a quick note because this group that we are working on, the systemic modeling group, is part of CLEA. But all this came out of a Templeton grant as well. So I saw that your project is a Templeton funded project, and I guess you went in the science of purpose, probably line, right?
Yeah, nobody else would fund me. Yes.
Yeah. Well, we got the
Right.
same. We got the
Yeah.
same type of funding. So
Great.
CLEA has that kind of funding too, and we started a project called the Origins of Goal Directedness in 2020, and we are about to finish now. So during that period, we started doing this chemical organization theoretical modeling of the notion of goal directedness, and we started stumbling upon agency and distinctions and all that. And we have a specific formalism that we have advanced over the project. And on the side, I started this research group with Christian Gendraco that shown a lot of interest on modeling artistic and creative processes. So then Matthew came along, and like all others in this group came along on the side through these discussions. So it's very cool that we have formed a little community around these deep questions, and I think it's great to have you, and hopefully maybe we can do something even in the context of the grants, given that we
That
are
would be
both
great.
Templeton funded. It's a sort of unexpected a difference that can make a difference, sort of
Given that we
in
have
a
the same
symbiosis.
interest, mainly.
Yeah,
Yes.
Yeah.
We
yeah,
should talk offline, as you suggested. So let's do that at some point.
yeah, yeah. Okay,
Great.
I'll get back
Yeah.
to you then.
Thanks.
Okay,
All right.
so yeah, so see you guys. Thank you very much
Yes.
Yeah.
for
Yes.
having your mental energy to stay here,
Yeah. Thank
stick
you.
around, and see
Thanks.
you in 2 weeks.
Yes.
All right.
Great. Thank you very much. Thank you very much.
Yeah, bye bye.
See
Thank
you
you,
guys.
Francis, for coming as well.
Yes.
Bye bye.
Francis, thank you very
Bye bye.
much.
Yeah,
Okay. Bye bye.
bye bye.
I think Tomas was gonna stay as well, maybe, or let's see. I
Oh,
just
sorry.
yeah.
Goodbye.
Yeah. Oh, see you. See you. See you. I'm just trying to figure out how to end this recording. Hey. Yeah. Okay. Okay.